All right, hi everybody. We're here, and I hope we had an excellent week with Python. Today we'll be rounding up hopefully the remaining part of the basics of Python, and then we can now get down real quick. At the end of this week, look at getting all the basics that are necessary. Right now, we've learned just at the recap, we've learned how comments work, we've learned the basics of data types, we've learned how variables work, we've learned we've understood some arithmetic. To play around with loops, for loops, at the basic, at the end of the basic rather, and there's also while loops. Then we play around with conditional, if statement, if else, else if, so on and so forth. We looked at modules, packages, libraries, how to import modules, how to create your modules, how to convert a file, a folder into its own package, and the hierarchy of modules to package. Then we also look at input, where you can allow a user to get data into your application, right? So these are the basic things we looked at, and I'm hoping that over the last few weeks, we have learned something new, we have gotten the best out of the basics of life. So the running up right away. And what are we going to be covering today? We're going to be covering in a few minutes, we'll be covering functions, we'll be covering file management, and then we can also play more advanced stuff using projects. Okay, so remember last time we met, we did a bit of age computation, right? And I remember this is the last week today. So ready to compute, you want to get data from the user. You say, okay, whenever you enter, compute the date, compute the age rather of the user. So let's just continue from there, right? What did we do last time? We were trying to put all of this in a single thread block. So we import this pattern, and then we get all of this information, written right here, and we want to do that in the second. Oh, sorry. So we enter this on there, 387, 1898. Which is your age 222, right? So we can, instead of having to always come back to this cell, we can wrap all of this around in what is called function. The function is a basic building block of reusability of programming. So let's wrap this in a function with something like this. Compute age, right? Define it to create a function. You just call it, write the name out, and we put brackets and put what is called the argument. So let me just define the function. Define function name, argument. So it's argument 1, argument 2, and so on and so forth. Right? Argument. Argument. Keyword. So with this, what you're allowed to do is you can do whatever, right, with the argument. and then we can return optional, which like so. Let's define something completely. In our case, there are no arguments right now. Okay, the arguments are we can see this information. We want to let's look at that indentation. We want to bring it to the picture. So if I run this has defined the function. So if I do q cube, if I want to call the function, I want to execute the function. The first block here defines the function. I want to execute the function, I just run it. So I hit enter with this. See? I'm not allowed to do that. That means you can always compute the age again, right? Do the same thing. See that way. Now, this is now how do you, for example, use really exploit the power of using these functions? Yeah. How do you really exploit?
Can you hear me now? I apologize for my. Okay. So how do you really exploit the power of using these functions, right? So now that we have defined the function, what we're going to do is let's now pass the value. So if I compute an age, for example, I want to use the age in something else. So for what we have done here, remember, we defined the function, right? We called the function twice. It executed, typical, right? Then the next thing is, how do we now reuse the function? So I want to say, if my name is Kelechi, for example, and I say, okay, Kelechi's age, right? It's now compute age, right? It allows Kelechi to enter his date of birth. So let's say my date of birth is 19th of, I don't know what that is that September? Yep, 1991 or 92, okay? And it says your age is 20, right? Now, if I run Kelechi's age, it returns nothing. If I print Kelechi's age, it returns none. Why is that? Even though compute age has executed, somehow it did not store that information in the right variable. Instead, it stored none. We know that I should be 28 years old, right? But somehow it doesn't show that I'm 28 years old. Now that is where functions now need to have what is called a return value. The return value of a function is defined by simply, I'm going to copy this again. So instead of after all these things that we have just done, we return age. Now, nothing seems to have happened. But when I do the same thing, and I enter whatever information I want, of course, the same thing that has happened before. Remember, we asked the age to print. We also asked this code is executed to print. But now if I call Kelechi's age, you see there in the past, it returned none. In the present, now it returns 22. Now we can multiply Kelechi's age by 365, right? And then we now have a valid number. In the past, because we were none, we couldn't really exploit the power of reuse of these functions. So with just this simple return statement, we can now really exploit the power of this, right? let's do it. Let's bring up a new example. Let's say that you wake up in the morning, you have a routine, and your routine is such that, oh, let's do a test. For those that are in this part of the world, there's a guy we call Two-Face, and he sang a song and says, I wake up in the morning, I stretch my feet, I say a thank you prayer, and I brush my teeth, right? So the first thing that is there is that he wakes up in the morning. So if it is the morning, he says a thank you prayer, and then he brushes his teeth, right? Let us write a function that does this. What's the first thing you think about? When you wake up, is it morning or not? So let us first put this in pseudocode. So first thing, wake up. Next thing, check if it's morning, right? If it is morning, oops, sorry. If it's morning, what do? Say thank you. And once you do that, brush teeth. Simple stuff, right? That's our pseudocode. We can now define a function called wake up. And the argument here is time, right? Because there's a time is going to wake up. We expect that you can wake up anytime, right? You can wake up in the afternoon, you can wake up in the evening. So we can say that we want to have a time, the time factor as an input to the function. So that if I want to run wake up as a function, I can always either pass morning, afternoon, or evening as an argument, right? Cool. So let's try that. First thing we are doing, what's next? Say if it is morning, right? So if time is equal to morning, these are tests for time. Simple stuff. Print thank you, right? Print brush, of course. Since that's probably the easiest way to say that we are brushing our teeth. So we can also now say so we can also do the next thing by saying, okay, else, right? If time is equal to afternoon, print afternoon, right? No need to brush teeth. Just some basic stuff, okay? Then else, print looks like you are woken up at the wrong time. Such stuff, right? Okay, so this is a simple function that executes what Two-Face would do. Of course, I'm a little more. So here we've created the function. So now if I pass the function without arguments, it tells me that, oh, you have an error, a type error. It is required to have a positional argument called time, all right? So what that means is that we need to pass a time is equal to, let's say, morning. And once we do this, it prints all of that. Prints thank you and brushes teeth, right? If we do the same thing for afternoon, of course, you should anticipate what will happen. It's afternoon, right? Excellent. How about evening? How about anytime? Of course, we know, because all of these extra ones fall in the else part. Now, you're the one that has to decide how you want to handle all of those situations, right? Okay, now that is that. Now, another thing you could also do, you could also define what is called default argument. A default argument is such that if the user, remember this case, we didn't enter anything in the argument and you return an error. What if you want it in a way that no matter what you enter, sorry, if you do not enter anything in the argument, you can at least have something like a default. So, I'm going to explain how that works. So that even if you don't enter anything, we can decide to say, okay, let's assume that everybody by default wakes up in the morning. And it's as simple as redefining the function. I did a copy and paste and changing just one thing. Time is equal to morning. Now, what this means is that if someone does not enter anything in the argument list, it assumes that it is morning, right? That's really it. That's really it. Okay, so I think that's the basic building block of how functions work. Of course, remember the function we just put together now does not return any result. Remember, because we don't have a return statement in our function. I know what to do. You just have to enter a return statement anywhere you want in the function. So we can say return time, for example. All right? We run this again, and if you look at it, there returns morning. Whatever we put, if I change this to afternoon, it prints the usual stuff, and it returns afternoon. Now you ask, for those of you that probably do not notice, why are these two things printing on different lines? Because I added something called an escape string. So when you are printing a string, you can, with the escape character called backslash, n for new line, means that instead of entering all this in different lines, I can just do backslash n, and it returns it in next line. If I want to do something else, there are other escape characters like backspace T, which is for tab. Let's run it again, and you see that it technically gives some form of space between them, right? I can decide to enter more just to prove that it works. Let's see. Okay, yeah, see that? So we can always go and learn how those string literals work. Thank you very much. Okay, so that's the basic stuff about function, right? And of course, what you could also do, let's say, you can create a function that actually really captures the current time, right? And something that tells the time, for example, yeah. And say, okay, you shouldn't wake up at this time. If it's evening, so instead of us passing the morning as a string, we can decide to pass the morning or the time as a real date time object. And of course, we've already done of those with string with the last class that we talked about, right? So that's the basics of function basics, and I think we are good. Next, we'll be talking about file management. Now, what exactly is file management? File management in Python allows you to manipulate, read, write, and perform some other operations on files in Python. So let's play around with a bit of file management. So let's say I have a file called, of course, you can read and write files in virtually any format. But for simplicity's sake, we are going to be reading in and writing out text-related files. Text files. So to read text files, we are going to use the simple keyword called open. Of course, open is simple English. You want to open anything, you just open it, right? Okay. Now you can open, I have a dictionary right here. Let's quickly check what the content is. It's quite long. Should I use this? Okay, let's use it. I'm using this. Why? Because it's probably going to, it's long enough so that you do not have, you can't cheat your way around it, right? So let's see. We have a long dictionary of words and their definitions, right? Yeah. And we want to read this the content of this dictionary into, maybe we should start with a sample. Okay, let's start with a sample. Simple sample. Simple sample text. Maybe when we do the sample, we can now talk about the more complicated. Let's look at a sample. So we have a simple sample. Yeah, this will work. We have a sample of a list of files I want to read from. The goal is to read the content of these files and pass it, manipulate, maybe add some more, use maybe the first or the second or the third or any other one you want to use in the file, in the object, right? Good. So let's say I want to extract something like nuclear. This is a file. I want to extract, say, nuclear from this file. How do we do that? You want to add something to this. How do we do that? You want to delete a couple of things from this file. How do we do that, right? Let's start with that. So I said before that I use open to read from a file. So if I do open sample, remember the name of our file is sample.txt. Yes, looks like nothing happened. Yeah, looks very crazy. But let's pass this information into a file. Right? So now we have a file object. And the name is sample.txt. The default, if you're opening a file, is in the read mode. Let us be sure about that. Let's do help. Right? I think it's best to find out yourself. So you can have your mode read. If you scroll, you see that you can either read, you can also write. You see that? You can create a new file if you want. Now, the interesting thing, you can also append, right? You can also read in binary mode. Binary mode is mostly for files that are not in text format, and you still want to be able to manipulate them as is. If you look at the default, like I said earlier, default is text, right? And some other options like reading and writing, which is plus, or this duplicated one, which I'm sure many of people use. But the most common one, and moreover, you can also combine them. So if you are reading a file that is not a text file, you can do RB, something like, let me show you. You can go through all of this later. So I can do open sample file.txt RB, right? So look at this. Here, when we did it in text file, it said it's a text IO wrapper, the name, sample, the mode, R. If I do the same thing here, oh, sorry. You see here that now it is in, it's no more in text format, right? But then, you probably, as you get some experience, you probably notice the difference between reading raw text files and reading files that are not text for manipulation, right? All right, moving on. Where are we? We are trying to read, yes, the content of a file. Now we know, let's go back and do this. Let's read this in text, default. Okay. So if we want to actually really read the contents of a file, right? We use the read string. Now see what happened here. Let me open this by the side so we are seeing the same thing that's going on. Now, if you look at the file itself, we have phytoterologists. Yeah, I'm sure that's some long name. These are technically English words, randomly picked from a dictionary. So look at these words. You see that the exact same thing is happening here. The first, am I correct? Then you see the new line, \n, which shows that we're going to a new line, and the next, right? And so on and so forth until the last one. So we've technically read the file, right? Now, what if we want to separate these files? If you look very closely, when you do the file.read, it returns these files as all your files together as a string. Of course, you can always test for that. Output, let's say, is equal to that, and you can print the type of output. Oops, I did not spell output well. You see, there's a string, right? So, because it's a string, you know exactly what you can do with strings. You can manipulate strings anyhow you want. Remember, we've read the file into a file object, right? Now we've passed the file to a file object, we've read the contents of the file and passed it as a string. We can just say file.read and we can split it. Now, when we do this, we are able, oops, did I do that wrongly? Oh, yes, that's correct. Sorry, we did this before, right? Remember that this is the content. And now I know why. Because we've already read it, we've lost the content of the file. So let's run this again. Let's run this again. So we can say output.split. Of course, if you do not know what to do with output, you can do dir output. I'm sure you've gotten the hang of this already. It tells us that there is a split, because it's a string, right? I can split it. I can also split lines, whichever way you want it. So output.split means I can now, you see now they begin to look alike, right? This time it has passed this into a string, into a list rather, just like this, right? And then, just like we did this list manipulation, remember we were talking about data types, we talked about lists, we can pass this information into a, let's call it words, right? So if we print the list of words, we have that, and we can return the fourth one, which is nuclei, right? So you see how we've been able to first read the content of the file right here into an object, pass it into a list. First, it came out of a string, right? We're able to use split, dot it out as a list. Then we can now extract the contents of the file one at a time, right? Sounds good, doesn't it? Yes, it does. Okay. So let's do some more interesting stuff. There's something you can actually do. Because when you open a file, right? Remember, the file is still open in your Python, what's the word? Your Python program. What that means is that if I try to make edits to the file in your normal file manager, Python has a lock on the file. You cannot make edits to the file outside this context. Now, it was that thing that we do that you probably have noticed. If you are working with network files, for those of us that work in network environments, once someone else has opened the file and you are trying to make edits to the same file, what happens? It may not work, right? Now, what do you do about it in that case? That means you need to close the file, right? Don't forget that you need to close the file. So, file, do not forget to always close it. And now, how do we close the file, right? Remember the file we opened, what was the name of the file? It is called file, right? So once you're done with opening the file, you just simply close it. And that's really all. You've opened the file using the open, you close the file using close, right? Now, of course, you may not always remember to always open or close a file. So the easiest way to go around this is to use something called context managers. Context managers allow you to run all your operations on a file in a block of code. You open it and pass that open into what is called the context, so that the moment you exit from that indented block, the Python automatically closes the file. That way, you don't lock down a file when you are not using it. I'm going to explain that in a moment. So context managers are implemented using the with keyword. So I do the same thing with open sample.txt, but just the same way we did earlier when we said file is equal to open I can say as file. Now what this means is that it opens the file and passes it into the object called file, just like we did earlier, right? So we cannot tell ourselves that output, like the same thing we did, is equal to file.read, right? What's the next thing? Once we do this, this means that once we are done with this, automatically you don't have to run close. It automatically closes the file for you. So we have our output out there. We can now do, of course, what we have always done. Words is equal to output.split. Same thing, and we are good, right? So that's really it. Of course, there's another thing you can also use with the, if you don't want to read all of the file at once, or you don't have to always do these two separately. We can do the same thing with open. Let's do this sample.txt as file. We can say output is equal to file.read lines. Oh, sorry, that should be read lines. So with this one now, you see what's happening here. It says that this helps us because when you do read, it reads everything from the file. If you have a very large file, right, and you want to just say the first 10 lines in the file, this allows us to just read the first X number of lines. So when we just read the first 3 lines, for example, it looks like nothing happens, but when you run output, you see here, it's quite interesting that it reads the first line, which is 0, the N, which is actually a line by itself, and then that's really it. If I change this to 4, did I miss something? Let's see. Hold on a second. Okay, hold on. Let me just change this to lines. 2, 1. Okay. So I apologize for that. Oh, my bad. You just run file.readlines, and it should just read all of. So instead of doing this step by step, file.read, and then have to start splitting, it just passes this directly into a list function, right? And that's really it. So now what this helps us to do, remember what the goal is when we put all of this together, is to do, let's come back here and one second, while this loads. Now we are trying to design a game, right? Where you read the content of a dictionary. Let's go back to our README. Let's not forget where we are. Okay? So look at this, right? The first thing we're going to do, okay, oh, I didn't put the pseudocode here. Hold on a second, let me show you. Give it one moment. Pseudocode loading up. Aha. So looking at the game we're trying to put together, right? We ask the player to choose a word length, let's say 5. A random word is generated, right? In this case, we're going to be picking up the random word from an English dictionary of words. So what that means is that we will need to read something that is very similar to this. Pick a random word from this place and then store it in memory. Remember, we are trying to create the hangman game. Let's not forget that, right? The next thing we want to do is that we can now start looping, create a loop. Remember, we learned something about loops, where each time somebody enters a character, it checks if the character is in the string. If it is in the string, it says you are correct. If it is not in the string, it says you are wrong. And it depletes your number of tries by 1. If you get to the point where you no longer have any number of tries, it tells you that your game is over, right? That's how the game works. So we've learned all of the building blocks to get to this point where we can now design a game out of this, right? So let's start thinking about it. I'm going to have to stop here, maybe so that we can start fresh with actually designing our first project, the hangman game, using all of these principles that we have learned so far. Remember the principles? We've learned conditionals, we've learned loops, we've learned arithmetic, we've learned file inputs. Remember file inputs? Yep. We've learned modules, we've learned functions, and so on and so forth. So we put all of these together, these 9 to 10 options, functions, or rather principles that we have learned, and put them together in a simple game, right? So I think that brings us to the end of the basics of Python. And what I'll say is, you can take a look at this pseudocode. I'm sure it will probably come in very handy, because next time we are here together, we're going to be implementing this in one fell swoop, and we'll be designing our first game, right? I don't know if there are any questions. Are there any questions? You can type your question on the, you can either type or just unmute yourself and then ask your question, whichever way.
Good evening.
Hey, good evening, sir.
Well done. Thanks for the great job. I still have some problem with updating my GitHub stuff. You understand? Like, I don't have all these your files now. Like for example, all the things you've taught now, it would be nice for me to be able to refer to this file when I'm reviewing the codes myself. You understand?
Yep.
Just even though we are following you, we are still teaching like an expert. Exactly. So, so we will still need to go at our own pace after the whole class. You get?
Of course. I recommend it anytime. Well, I always say that just come back. Look at this, for example. Just come back and clone it. Just clone it. And yours. That's really it. So you can clone the original one.
Okay.
So how do you clone? Simple. You can do git space clone, or if you're using git desktop, you just click on open in desktop, and it will open your desktop. If you want to download the file, you download the zip file. If you don't have GitHub, right?
Okay.
Simple as that. Yeah.
All right. Fantastic.
Right.
Yeah. Of course, I can always reach you if I have questions. Now, let me practice all these things first.
Please do.
Is it lost to consume? Thank you very much.
You are welcome. Okay. So finally, I just like to add that if you need any form of help, you'll be surprised that help by itself actually works, right? So if I do help, you can type anything in the help box. So you want to learn about string. It tells you how the strings work, and you can learn a lot about it. Of course, it can get very, 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 yeah, it can be very, very time consuming. But then you don't have, of course, this is when you are trying to run around help. If you have a specific challenge about anything, say you can just create a simple variable and try and understand the help item about the variable. So if I just create a simple age is equal to 22. I don't know what to do with age. I can just do help age. Just a minute. I need to stop this. Okay. I think my help has frozen. I need to that exists. Okay. So if I run help for age, it should just tell me that, oh, what are the various, of course, which is still very, very long. If I want to learn about the age functions and methods, you can just pick the ones you want. For example, real converts this to real number, extracts the real portion of an age of an integer. If there's an imaginary part for those that do mathematics, and so on and so forth, right? You can learn it. Python is so open source that everything is actually out there. There's nothing that is hidden if you are learning a lot of this stuff, right? Yeah, I think that should be it. I think there is one more thing we probably need to when we start doing the game. We are going to be touching on something called object-oriented programming in Python. But let's first do something fun. Let's create something that we can tell ourselves that yes, we have a project in our arsenal. That yes, we have created a project to run with. Then we can now that's under functional programming. All this we have learned right now is called functional programming. And the next we're looking at is object-oriented programming, right? Of course, we've done some object-oriented programming stuff right now. Yeah.
Really.
Then we can start doing OP next. Yeah. So next time we'll be looking at designing our own game. Remember, we have pseudocode here. I think you should take a look at it, see if you can do it yourself. All right, just try your fingers around this. All right, ask the player to select a difficulty. That means you need to create a couple of things that define difficulties. Create a random word, or rather pick a random word from the English dictionary, then give the player a couple of times to try to guess the word, right? The moment he's able to guess it, you tell him that he's correct. You know, if you have played Hangaroo or Hangman, I think it's Hangman it's called. Then I used to call it Hangaroo. If you played Hangman, you probably have a hang of how this game works. And I'm sure you'll have fun, right? Okay. So thank you very much. If you have any questions, you know where to reach me. Reach me on WhatsApp, Telegram, email. I'm sure I send a couple of emails to the attendees of this once in a while. If you think my emails are too much, please send me a message and I'm going to take you out of my mailing list. If you think they are too few, tell me to send you some more. I'm going to send you some more, right? All right. Thank you so much for the time and the opportunity. I'm sure, yeah. So enjoy yourself, guys, and have a good one. Yeah. Bye.
See you next week.